All right, everybody, welcome back. We're going to be working on building out job number 4 today. So I got my project board and I've got my job sheet. So those of you that did not stick with me live and work on job 4 together, this is the drawing for job 4. We've got our floor plan, cable diagram, and wiring diagram. All right, so take a screenshot of this and make sure you get this down prior to working, and this will help you out. All right, so here we go. Remember, the floor plan is like our shopping list. So before we start the project, we have an empty project board. I got an extra couple wire nuts here. I'm going to go shopping. I need a single pole switch, a lamp, and a duplex receptacle outlet. So that shopping list or the floor plan is going to tell me exactly where the items are going to go and what items I need. So just like the drawing itself, I've got my duplex receptacle outlet, my light, and my switch in that same order as the drawing to make things easier for me. The cable diagram. All right, now we're going to focus on the cable diagram. The cable diagram shows us the types of cable that is going to be running between our electrical boxes that we've just explained. So I've got 3 separate pieces of 14-2 going into this project. The home run is the power supply. That's what we're going to connect to the power supply up in front of the classroom, or you connect to the circuit breaker of your electrical panel of your house. If you're testing inside the classroom, we work off a low voltage power supply that's a little bit safer than the voltage coming out of your house's electrical panel. If you take electrical trades next year, we get into the full voltage that is offered at your house. A little more dangerous, but we could do a little more cool control work type things. Okay, so here we go. So 14-2 from the home run to our duplex receptacle outlet. So here's our duplex receptacle outlet. We're going to run a 14-2 from the power supply to this location. So this length of wire doesn't have to be very long at all because this is going to connect to our power supply, which is up front of the classroom. So I just need a short piece with 6 to 8 inches exposed conductors on both sides, and that will allow me to connect this cable to where I got to do it. So 6 to 8 inches long is what I'm going to rip the cable at on both ends, just like we've done so many times with the other jobs in the past. We got that paper, not needed, cut that out of there. The other end, same story, 6 to 8 inches. Notice how when we use the cable ripper tool, it's not a very difficult thing. It's not a strength game, it's a skill game. So if you're using that tool and it's creating a challenge for you, something's wrong. All right, so 6 to 8 inches of wire into the box, ready to make my connections. So I'm going to finish the cable diagram before I make any splices whatsoever. So back to the diagram, I'm going to have a 14-2 from my receptacle outlet, which was this box right here. 14-2 to my light box. So I need to get a cable from here to here. Same story. I'm going to get a predetermined length. I got a piece of scrap out of the scrap wire bin in the back. I'm just going to go ahead and make sure that this is truly 6 to 8 inches long. If we make it short, if you try to make it like 3 or 4 inches long, it just makes things more complicated and difficult for you when it comes to making splices, especially if you make 1 or 2 mistakes during the splices, the wire just gets shorter and shorter. It makes things more difficult for yourself. So we always make sure we have that nice 6 to 8 inches of length on the ends of the wire, or I should say cable, and that makes things a lot better for us as far as build out goes. Okay, from the outlet to my light box. Now, the outlet is using a plastic box, a single gang box. And there's knockouts on the sides that you might not be able to see with the camera angle, but they've been used and abused by students over the years. So the wire has a tendency to want to fall out of these. We just kind of bend and hold the wire in place so they could keep their shape and stay there. The metal boxes, on the other hand, have these internal clamps or external clamps that help hold the wire in place, and those will use a screwdriver to fasten when we're ready. So I'll get my cable in like so. All right, so we've got this cable. Oh, drop tool. Complete. Now we're going to go from our light outlet to our switch with our 14.2. Remember, this dashed line is not cable. It's not wire. It's not a white wire. These are floor plan symbols. This dashed line from the switch to the light is our switch leg. All this is doing is telling us information. This tells us the switch is controlling the light. Do not be confused thinking this is a wire or a cable. This is the cable, 14.2. So from the from the light to our switch, we're going to run another 14.2. So I'm going to grab a piece of scrap wire that's long enough to reach between the two, and we'll run those 6 to 8 inches long. Cable ripper. As always, I was always taught in the world, short wire is an expensive wire. And that was the idea, that if you cut a wire and it did not reach, it's kind of a useless wire and it turns into garbage. So they call it an expensive wire because nobody can use it and you have to throw it away. So we always make sure our conductor length is nice and long. And we go ahead and tighten up that internal clamp, and it'll have about 1/4 inch of that white sheathing exposed into the box. Not too much, but just enough so we use that white sheathing of the Romex cable as a little extra buffer so we don't damage the conductors underneath. And then the other end is going to go to our switch box. Same story, strip the wire, 6 to 8 inches long. Mr. Ron, my hands aren't as big as yours. That's fine. You guys could use a ruler. That is a little not really productive in the real world, but if your hand is a little bit smaller than mine, remember, you can always go, all right, this is about 5 inches, so I need to cut a little bit longer, okay? And that's an easy way to do it. So last but not least, we're going into the switch box here with our last piece of Romex. So on the project board, I've got my 3 cables. Let me get some of this scrap out of here for you. Okay, so we've got the 1 cable, which is going to be for our home run, connects to our power supply. A 2nd cable is going from our receptacle outlet to our light, and then from our light box, a 14.2 that finishes off at our switch. So 3 cables on the project, just like we looked at on the cable diagram. The cable diagram is done. So believe it or not, we could really kind of ignore everything else but the wiring diagram at this point. And that's one of the more difficult things. That's where people get a little bit panicked when they start to look at things, because that wiring diagram shows you a lot of information. It shows you where the splices and connections are and the actual terminals on the devices themselves. So let's go. We'll start with the outlet box. We'll still work from right to left as we're doing our work. And just like we draw it, we've drawn it always our grounds complete first, then our neutrals, and then our hots. We're going to do the exact same thing here with our wiring. So we're going to do all of our grounding first in the wiring. And I'm going to show you exactly what this looks like on the project board now. So our duplex receptacle outlet's going to go there. We have got 1 green screw on the duplex receptacle outlet. We have got 2 bare copper wires inside this box. So when we have these 2 wires, 1 green screw, we're going to have to make a splice with a pigtail or scrap piece of wire that's going to allow us to turn those 2 copper wires into 1. So I'm just going to go ahead. I got myself a piece of scrap bare copper, which is about 6 to 8 inches long, and I'm going to connect that to those 2 existing bare copper ground wires, like so, right? Clockwise goes to splices, trim, wire nut, nice and tight. And now the other end of that is going to be the end that connects to my green screw. So I'm going to bend a hook on the end of this to attach to my duplex receptacle outlet, like so. Clockwise goes to the hooks always. Nice and snug. Good. That's going to last forever. Okay. Grounds in this box are done. Moving along to our light box. Our light is made out of porcelain or plastic. It's not conductive. It does not have a ground screw. It just has the neutral and the hot. So if we look at the metal box, inside there hiding is actually a green screw. So that metal box is going to take the place of our ground. Once again, 2 bare copper wires, we need to turn them into one bare copper wire. So we're going to use a piece of scrap again to do that. So piece of scrap, bare copper, 6 to 8 inches long. We got our 2 pieces inside the box, 3-wire splice, and the other end of that scrap is going to go to that green ground screw to complete the ground for this light box. Wire nut clockwise, nice and tight. And the other end of this is going to get the hook. Notice how I leave this long, 6 to 8 inches long. Why do we leave this as long? That screw is real close. We can make this wire a lot shorter. But if we switch to a nicer light fixture that is made out of metal, maybe that will have a ground screw. So we want to keep this nice and long for future. A lot of the stuff we do in our world here is based off of anticipation of what's going to happen in the future. It's almost like you've ever heard the phrase future-proofing something. We always kind of want to make sure we future-proof our electrical installations to make life easier for the next person that comes along in a couple of years. Okay, grounds are done in this box. The last box that we have here is our switch box. And just like everything else, everybody gets grounded. The switch, 1 green screw, 1 bare copper ground wire. This makes life very easy for us. No splice is needed. We're just going to bend a hook and we're done. Like so. Clockwise, tighten up that screw terminal, nice and snug. So nothing's moving on this. Okay, the entire project, our grounds are complete, just like our drawing. We've done our grounds first. We've grounded every single box on our project board. Now we're going to do our neutrals. Who gets a neutral in this circuit? We know the thing's using electricity. So our outlet and our light are going to get that neutral wire. So let's start with the outlet box. Once again, we've got our 2 white wires. So I'm going to splice these 2 white wires together with a scrap piece, and we're going to connect that scrap to our duplex receptacle outlet. Now, some of you might say, Mr. Marley, can't we bring both these white wires to our outlet? Yes, some people actually do that, and it is allowed by code, but it's not the best job. The best job would be for us to do it this way, because if there's a problem with that outlet or device, the way we're connecting a scrap wire to it allows stuff further down the road to continue working. If you use the outlet as a splice, this would not happen. Notice how once that wire nut goes on there nice and tight, we don't see any exposed copper. The other end of this, about 6 to 8 inches long. We bend our hook. Like so. And then on the outlet, our long eye is our neutral side. Our silver color screws are our neutral. And they even say it sometimes in the back. They write the word white. And this is all review from the last few jobs we've done. Does it matter which one we go to? No, there's actually a little metal bridge that connects these 2 screws together. So connecting to one is like connecting to both of them. Clockwise, nice and snug, and we're done with our neutrals here. I'm going to leave this alone. Now things get a little bit tricky inside this light box. All right, so if we look at the drawing, the white wire coming from our receptacle outlet. So I got to find that white wire. That's this guy right here. Is going directly to my light fixture. It's not splicing onto anything else. That's the splice I just made, directly to the light. This white wire, bend a hook on it, go right to the light. This is the end of our neutrals, believe it or not. Don't worry about that white wire yet. We didn't talk about that, but the light fixture is the last thing in this circuit that's using electricity. So I can just bend a hook right on the end of it, connect it clockwise to the screw. Remember, silver screws are for our neutrals. Nice and tight, snug, good to go. Neutrals are done here. Neutrals are done here. Just like the drawing, they're done. Okay, we've got our grounds done. We've got our neutrals done. Now comes the hots to control. So we have to kind of remind ourselves what's happening in the circuit. Our switch is controlling our light, and our outlet is going to always be on. Okay, I want to make sure that outlet stays always on. So that means the home run, the power supply, the hot wire coming from the home run, it's going to splice a 3-wire splice, 1, 2, 3, and one of those is going to go off to my outlet. So in this box, I've got these 2 black wires and they're going to join together with a scrap piece of black wire and connect to my duplex receptacle outlet. When I strip the wire, I strip it about the length of my thumbnail, which is 7/8 of an inch, and that will give me plenty of copper wire exposed to make a nice solid splice or screw terminal connection, if that's what we're doing. So the magic number there is 7/8 of an inch, which is the length of my thumbnail. Once again, you could check or double check or measure yourself when you get into class, and you can say, all right, I got to cut a little bit more or a little bit less. All right, 6 to 8 inches there. Strip the end, bend a hook, and this is going to go off to the short eye side, the brass color. It even says hot wire sometimes on the back. Same story. They're connected. They're bonded together. It does not matter which one I connect to, as long as my hook's on there clockwise, and I snug it down to make a nice solid connection. This box is 100% done. So that last control wire, that hot wire splice I just made, was right there. Outlet's done. Now, the black wire coming from the receptacle outlet is going to make a really funny splice here. It's going to splice onto the white wire going off to the switch. Mr. Maraldi, he told us switches don't get neutrals. Yes, remember, this is what we call the switch loop. We talked about this live during the review of this job sheet when I did this with the class. We're using a white wire to act as a hot wire here. So the black wire from the receptacle is splicing on the white wire to the switch. Black wire from the receptacle, splicing on the white wire going off to the switch. 2 wires inside that wire nut, nice and easy. 7/8 of an inch. And we just splice those two together. It's only a 2-wire splice, makes things really easy for us. Wire nut nice and tight. Bang, we're done with this box. So now that white wire we spliced onto goes off to the switch. When the switch turns on, it brings the hot, controlled hot, back on the black. So now we know that when the switch is on, that outlet's going to be on. So the black wire is going to go to the outlet. I'm sorry, to the light outlet. Black wire to the light directly. Bend the hook. Brass color screw. You always bend those wires. If you see I'm doing them pretty quick, I'm manipulating the wire with my fingertips to make it work for me, okay? Copper's malleable. And this is done. Now I'm stuck with my switch. And my switch has those 2 screw terminals on the side. I've got a black wire, I've got a white wire. They are no longer hot and neutral because of this really strange splice we made right here. So that white wire brings power to the switch, and the black wire brings it back. So both of those white and black wires will go directly to the switch. It does not matter which screw terminals they go to, because when we flick that switch, it's just connecting or disconnecting these screw terminals. So this is an easy one. We bend hooks on the ends of these and connect them to the switch. And believe it or not, folks, that's it. We are done. So I'm just going to trim that down here. Bend my hooks on the ends of my wires, and then connect them directly to my switch, and then the job is complete. All I need to do at this point after this is throw a light bulb into my light, and I would plug something into my outlet to test that as well. And when I'm done with this project, the switch is going to control the light, and that outlet is going to always be on. Shebang. And that's it, all we wrote. I don't really screw these down in class because we want to check your work. So we leave things kind of flopping around so we can easily see what's happening. But this is it, okay? So I've got my 14-2 from the power supply. So this end, every project we do in class has this kind of left at the end waiting to get connected to the power supply, all right? To my receptacle outlet, from my receptacle outlet to my light, from my light to my switch. And that is based off of the drawing that we've done together, all right? So once again, here's your drawing. We want to make sure we have a copy of this in our notebook, and we have an understanding of the project that we just built. And this is job number 4, folks. All right, good work. We'll talk to you soon.